The point slope form for a linear equation, for a linear function, is just another way of writing the equation for that function. Usually what you've been making in class has been what's called slope-intercept form. Because the actual form is y equals mx plus b, and m is the slope and b is the intercept, the y-intercept specifically. When we have point slope form, well, we have the slope still, so we still have an m, but we also have a point. And the point is defined by these two things, y1 and x1. The x and the y, they stay x and y. Those are the x and y that we would use here. But the x1 and y1, they correspond to an actual point on the graph. So if I had the point, say, 2, 7, then my y-coordinate is 7, and so I would plug that one there. My x-coordinate is 2, and so I would plug that one in right there. We'll see an example in just a moment, but I do want to show that you kind of already have a sense for this, just based off of the definition of slope that you've probably learned in class. When we are looking for slope, remember, the definition for slope, or the formula for slope, is usually written as y2 minus y1 over x2 minus x1. And if you haven't talked about this in class, you've probably seen it in your textbook at least. Well, when I have a point slope form, I only have one point, and so we'll say that it's, well, y1 and x1. And so this y2 here, I'm going to make that go away. And the x2, I'm going to make that 2 go away. So I'm just talking about x and y in a general sense. And then what I can say is, all right, well, I'm just going to multiply this whole side by the whole thing in parentheses, x minus x1. But if I'm going to do it to the right, I have to do it to the left, x minus x1. You can kind of see what's going on here. Because the x minus x1 down here cancels completely with that x minus x1, leaving me with just the y minus y1. And then I have m times x minus x1. So the point slope form for the equation really just comes from the definition of slope. It's actually a little bit of an easier way to get the equation for a line, because we don't have to mess around with finding an intercept. If you're told the intercept, then just use that. But if you are told a point, any other point that isn't on the y-intercept, we could use the point slope form. And then possibly convert it to slope-intercept form, which is the first example that we have here. I want to find the equation for a line with slope negative 1/3 that passes through the point negative 5, 2. Remember again my format. So it's y minus y1 equals m times x minus x1. Here, then, negative 5, that's x1. 2 is y1. So then y minus y1 is y minus 2 equals the slope, negative 1/3, times, in parentheses, x minus negative 5. I'm subtracting a negative 5, though. I'd like to not be doing that. When you're subtracting a negative, of course, that means that you are adding, and so instead, I'm going to write that as just simply x plus 5, and that's my point slope form. Be careful of the signs. It is important to remember that by default, we switch the signs. In the actual form, the format here, we do have subtraction signs in there. So you have to change the sign of whatever number you're plugging in. When we want to convert this to slope-intercept form, then it's just a matter of solving for y. So I'm going to take that negative 1/3 and distribute it. I get y minus 2 is equal to negative 1/3 x minus, well, 5/3, because remember I could write that as 5 over 1, and then 1 times 5 is 5, and 3 times 1 is 3. And now if I want to finish, I got to add 2 to both sides, plus 2 plus 2. I get a y on the left, negative 1/3 x, and then negative 5/3 plus 2. All right, negative 5/3 plus 2 is equal to negative 5/3, because I can make that v over 1, get a common denominator of 3, so that would be then times 3 on the bottom, times 3 on the top, so 6/3, and that gives me negative 5 plus 6 is 1, 1/3. And so there we go. Y equals negative 1/3 x plus 1/3. That is our slope-intercept equation. And this is useful if we're going to graph it, although 1/3 is kind of an inconvenient point to graph. So it turns out a lot of the time, when you have a point-slope form for the equation, we don't really bother to convert it to slope-intercept form, because we can graph it just from that. Let's do that. Y plus 7 equals 1/2 times the quantity of x minus 4. First thing we need to do is figure out what point. Clearly the slope is 1/2. We got that. But what point are we talking about here? Remember, we were looking at the x, we're looking at the y. We have the x coordinate right here, we have the y coordinate right here. You might be tempted to say that the point is negative 4, 7. But be careful. Remember the fact that the general form for the equation has negatives in it already. And the only time we get a positive is when the number in the point was a negative, was when the coordinate was already negative. So this is actually totally backwards. It should be positive 4 and negative 9. In the way, or negative 7 rather, in order to get that positive 7, it must have been negative to begin with. So 4, negative 7 is my actual point. And so then I go and graph that point. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And then from here, again, I know that the slope is 1/2. So I'm just going to go from there like I would on any other graph. It doesn't matter if I'm on the intercept or on any other point. I'm going to go up 1 and over 2. Up 1 over 2. Up 1 over 2. And then backwards. Down 1, back 2. Down 1, back 2. Down 1, back 2. Fill in enough points that I can fit onto the graph and then connect them. And there's my graph. So there we have it. Last example. We have a graph already drawn. Notice that it doesn't really go through the y-axis quite nicely. It looks like it's somewhere between 2 and 3, a little bit closer to 2 than to 3, but it doesn't appear to go through as an integer. This is why point-slope form is very useful. First, when to find the slope. When you have a graph, that's easy to do. It's up to and over 1, 2, 3, 4, 5. So with our rise over run, we have plus 2 going up and plus 5 going to the right. So the slope then is 2/5. There we go, 2/5. For the point, take your pick. We got a bunch of them. We got the point 7, 5. We have the point 2, 3. We have negative 3, 1. We have negative 8, negative 1. Any one of those points will work. For simplicity, I would recommend picking the one that doesn't have any negatives in it at all. Because that way we don't have to worry about accidentally messing up. Should this be negative? Should this be positive? When I'm writing it in the equation, I just have that 5 is the y-coordinate, so y minus 5 equals the slope, which was 2/5, times x minus 7. We could also say y minus 3 is equal to 2/5 times x minus 2. Or take that point. Y minus 1 equals 2/5 times x minus negative 3, so plus 3. Or we could say y plus 1, that looks more like an x. Y plus 1 is equal to 2/5 x plus 8. You don't have to give all of them, just give one. As long as the point is correct and the slope is correct, it really doesn't matter which equation that you give.